Today, we will talk about the traditional top charging coke oven. Top charging coke oven operations are the most mature production process in industrialized coke manufacturing. The fundamental theories of modern coking technology are all derived from it. The application theories in the steel industry also originate from it. Therefore, the steel industry is naturally very familiar with using coke produced by top charging coke ovens. This leads to the price of top charging coke significantly higher than that of stem charging coke. It is widely believed in the industry that top charging coke plays a unique role in blast furnaces. However, the opinion that top charging coke ovens must use more primary coking coal is worthy of discussion. This is because coal bulk density and coal rank can be dynamically combined and optimized to complement each other. Higher bulk density facilitates coal caking and improves the microstructure of coke. A proper blend of coal ranks can achieve the same effect. Regarding certain characteristics in blast furnace operation, we should pay more attention to other elements in coke. For example, stem charging ovens can use more gas coal. Gas coal mostly belongs to Jurassic coal, which generally contains more potassium, sodium, calcium, and magnesium. The increased volume of these elements may result in the stamping process failing to meet the requirements of large blast furnaces. Therefore, the top charging coke oven process is facing the following issues. First, the relatively low bulk density of top charging ovens only affects the coking performance. It does not create any irreplaceable or unique advantage in blast furnace compared with other processes. Second, top charging ovens are more difficult to improve coke strength. In most cases, top charging ovens require a higher proportion of primary coking coal and other strong caking coal. Especially under the current consensus in China, higher requirements are being placed for such coal grades. However, since the reserves of primary coking coal resources are gradually dwindling, costs of top charging coke keep increasing. Third, through the adjustment and optimization of coal blend, stem charging ovens can replace top charging ovens and fully meet coke requirements of large blast furnaces. Technically speaking, this is out of question. Applications abroad are already well established and highly mature. Domestically, breakthroughs are only a matter of mindset and time. If we insist that top charging ovens possess irreplaceable process and product advantages, or that the top charging coke price against stem charging coke price should remain significantly higher, then in the future, we will inevitably face increasing operational pressure and risks. In fact, the application of top charging coke ovens is also evolving. How to leverage strengths and avoid weaknesses has already seen multifaceted development and innovation, both domestically and internationally. Among these, the most effective approach is to start from research on research utilization to address the issues mentioned above. For example, first, select in a targeted manner low price 1/3 coking coal and gas coal with suitable macero composition and elemental contents that are conducive to improving hot strength, so as to offset the strength disadvantage caused by lower bulk density and reduce the cost of the coal charge. Second, make use of the characteristics such as lower expansion pressure and easier coke pushing of top charging ovens to use lower cost lean coal, especially those with higher expansion pressure, to increase expansion pressure and improve the microstructure of coke. Third, by adding an appropriate amount of cold-pressed coal briquettes to increase the overall bulk density while ensuring that the briquettes melt synchronously with the overall coal charge so as to increase the usage of non-strongly caking coals. If you have any questions, please contact the Essex Coal customer service or send me a message directly. See you next time.